Hello, my name is Renan. I will now start our Capstone project final presentation. We developed the Aircraft Safety Inspection Information app. Our presentation will cover six main topics. Recently, several aircraft accidents have increased public anxiety about flying. However, regular passengers have almost no way to check the condition of an aircraft before boarding. We wanted to solve this by building a system that provides reliable, accessible safety information to everyone, not just the airline. This slide is project topics and goal. Real-time safety inspection before boarding, monitoring at least 5 critical aircraft components, reflecting 95% or more of maintenance recorded, and providing AI-based safety scores and color-coded risk indicators, and showing recent and upcoming maintenance events, all, always updated, and meeting GDPR, aviation security, and FAA legal requirements. Initially, we used Firebase and TF-Lite. However, learning TF-Lite model on Firebase function was complicated and unreliable. Loading large TF-Lite model in Flutter causes compatibility and performance issues. So we switched to AWS Lambda with API gateway. This let us load our Saves model AI model easily in a container environment, connected with the Flutter app in seamless way, and scale or maintain the system with minimal cost and hosts. Our app is built with Flutter and currently support Android. There are two main interfaces for user. Enter the flight number, get safety status, and if needed, recommended alternative flights. For administrators, log in with Cognito, then register, view, or update aircraft data. We focus on responsive design, optimized fonts and spacing, customized snack bars, and clear loading indicator, all managed with simple set state logic. We use a single Lambda function to handle two API paths. First one is check for user request with no authentication. The other one is admin for administrator request with Cognito authentication. We store sensor data in DynamoDB table. Flight sensor data for all aircraft info. Flight recommendation cache for caching alternative flights. Admin login use Amplify and Cognito, and the app automatically added the ID token to the authorization header for a secure admin operation. We trained our abnormality detection model with TensorFlow and deployed it as a Keras file to Lambda. Input 5 types of sensor data, including hydraulic pressure, fluid temperature, brake wear, and fan blade wear. When a user checks the flight, Lambda learns inference in real time. If the flight is abnormal, we recommended a safe alternative flight from the same route. Our model achieved about 95% accuracy with synthetic data. This page is how the process works for user. Enter the flight number in the app. API gateway send the request to Lambda. Lambda learns the TensorFlow model in Docker container. The result and data are saved to DynamoDB. The app shows if the flight is normal or abnormal, and if needed, suggests a safe alternative. During development, we faced several technical challenges. First is key error body. Sometimes the event structure didn't include body, fixed by using events.getBody to prevent crashes. Next one is Flutter JSON parsing. Lambda's response was double encoded JSON, parsed twice in Flutter to extract the real data. Next one is DynamoDB decimal serialization. The decimal type causes JSON error. Convert to a float before returning responses. Next one is Lambda Flutter test different. Infrastructure was different between Lambda console and real app. Matched Lambda code to actual app recast format. Next one is user admin request confusion. Mixed both in a single lambda, causing logic error, split endpoints, and branched logic bypass. Lastly, null sensor data. Only the abnormal result was returned. Sensor values were missing. Modified the response to include all input data. We quickly identified the root causes and fixed each issue step by step. This slide how our system works in practice. Let's watch a short video showing the system in action. Now, I will briefly summarize how we achieved our main goal. First one is real-time safety inspection. We monitor 5 key components and reflect our over 95% of maintained data. We focused on common failure parts of the Boeing 737-800 using synthetic data for testing. Our AI model was with TensorFlow Keras detect anomaly and shows the safety score with color indicator like green for safe and red for risk. The model accuracy is about 85% or higher. We provide up-to-date maintenance histories and schedule inspections. Any new data entered by the admin is saved instantly and can be built right away in the app. Lastly, our system meets legal and security requirements, including GDPR and FAA rules. We confirmed with Rofom there are no legal issues as long as the airline agrees and the contract-specific data handling. Our app helps passengers feel safer by allowing them to check flight safety before boarding. If a flight is abnormal, the app automatically recommended a safe alternative so user can quickly find another option. Admin logins is secure. The app stores the token for authorized access and log out automatically when closed. Finally, our system can be expanded to train, ships, and more. We also plan to add a feature like user flight histories and better data visualization. Thank you for your attention. Thank you.